Today, we have two parts in the lecture. The first part about UML class diagram. Even though this course is a programming course, it doesn't talk about software design, because maybe later during your program you will get other courses that talk about software analysis and design. We are going to collect requirements from the user and make this object-oriented design. But I think that it's good to have this here, because normally when you deal with any project, we talk about object-oriented, we have to see the structure of your program based on the concept of classes and inheritance and polymorphism. So since you are going to use your style in your coding, and most probably in most of your programming language, not only in Java, most of your programming language later that you are going to deal with it, that they are compatible with object-oriented. So you will not go start writing different classes before you think, okay, these classes, or how many classes I should have, if there is a relation between these classes, if there is inheritance between these classes, how I will do it. So in this case, you need first, before you start your code, when you will have the requirement, to create something we name it a class diagram. Again, I will give you a general overview. It is out of the scope, but it's very important to share this with you. And I think also you need it for your project, because I will publish the project this week. I have already waited till you finish the vacation, and I will publish the project this week, because I already shifted the assignment, and then I think that now it is a time to publish the project that you can start with this. So today, I will show you how you can construct a UML diagram, and we will go to a case study and see how we can go and write a code for this case study. So first, when we talk about the class diagram, we saw this diagram based on the UML standard. This is UML standard. People who work with software analysis and design, they know the standard well. So why we talk about the standard? Because when you will write any diagram or any chart, so you will expect somebody else is going to see your diagram. So this person, he or she should be able to understand what you are talking about this. So there are a lot of diagrams that you use in UML for software design. As I said from the beginning, we just pick the class diagram today. So in the class diagram, you will have a set of classes, and then you will resemble each class in this diagram as a box or as a square, where you will have the class name, and then you will have the attribute and the operation, or the method, or the functions. Plus, there should be a relationship or the association, because you will never find a class diagram where you will have a class that is not related to the other classes. When I talk about relation, which means that relation later, which means that you are going to use an object from this class. For example, if I said A had a relation with B, which means that later either you will create an object of B in A to use it, or the vice versa. And sometimes the relation, it will be like the inheritance. It is also a relationship between these classes. So each kind of a relationship you are going to mark it in your diagram. So at the end, this diagram will give us a good overview about how many classes you are going to implement, what is the relationship, what is the inheritance, if there is inheritance between them. And normally, most of the time, there is inheritance you have to consider. Here, the multiplicity. So the multiplicity, which means that it can be 1 to many, or sometimes you have going to add special 2 to 4, but normally we will go 1 to many, 1 to 1. Sometimes we need this many to talk about it, which means that how many we expect. I will let you see an example. Before we'll go to this class multiplicity example, let's talk more about the attribute type. In the list of the class, you are going to add the attributes that you will have and the type of this attribute. Integer, Boolean, string, double, float. And since we talk about access modifier when we talk about object-oriented, and this is a UML for an object-oriented design, which is you expect later to use object-oriented programming for this. So when you are going for each class, like this class table, talk about what different attributes we will have in this class. Also, you are going to talk about if they are going to be which kind of modifier. So if it is public, we'll use a plus sign. If it is private, we'll use a minus sign. If it is protected, for example, we'll use the hash sign. And if it is like the default one in the Java, which is the package one, we'll use this sign also in this case. It is an optional one. We are talking about if there is a value range for a special attribute, you can add them. Most of the time, you don't add them, but if you feel that the person is going, because as I said, that sometimes who's going to make the design of the system is not the same person who's going to make the implementation. So you should consider this, that sometimes you are going to add in your diagram the range of the value of this attribute. So again, why we should the design have it and diagram we should have it? The same like when you are an architecture engineer. Before you start building a home, you should make different maps, and you should make different diagrams about different construction aspects and different construction levels that you are going to have. For example, how will be the electricity installation? You should have a map for this. How is going to have this heating system? You should have a map for this. How you are going to put the main infrastructure, they should have a map for this. The people who is going to construct and start with the construction operation, they will not sit like this, okay, I will put here a wall, I put here this pump here. No, it's not like this. There is a predefined plan that you have to follow it while you start your construction. What do you think, Kirsten?
Sorry, I'm eating 1 second.
So, no, go ahead, finish, and you can talk later.
Okay, I'm back. Sorry about that.
No, we are sorry that we disturbed your eating.
So, what was the question? Was it about multiplicity or was it about your analogy?
No. It's all about if you are going to construct a building, you should prepare all different maps concerning how you are going to construct and the infrastructure before you start construction.
Yeah, no, I totally agree, and I think that it's really important to have something like here that the map has to be extremely like explicit. Like there shouldn't be any ambiguity in it, because the person, like you said, the person that's going to be implementing it might not have any association to the idea itself. They're like
normally when you will go to work at the market, there is a person, we name it business analyst or requirement, who is going to collect the requirement from the client. He's not be the same person who is going to implement and code. He will make this requirement, and somebody else who is the software architecture or designer, he has to transfer the requirement to a software design. And then the coder or the person who is going to implement will pick up the design of the system and design of the classes and go start implementation. But since now you are doing an implementation based on a project that you should prepare it, This is why I highly recommended that before you start your class, your project implementation, write down the class diagram. And since we should all agree in the same way how we are going to describe different classes, different methods we have it, and different variables for each class, plus the association or the relationship between these classes, plus the inheritance that we will have it. This is why you should learn how you make a UML class diagram, because it is a standard model to create a class diagram. So here we can see that if you start with this first we are going to start to make the different classes, and then we can go ahead and do the different association. So if you're talking about this example, we have a class table here. So if now I can go ahead and see, look at, so I know now there is a class named table. It has 3 variables, number, places, total table, and the type for the first number is integer, the type for the second number variable is places, the type for the third variable is integer. The first 2, they are private, the third variable is public. The same for the method. I can know the return of each method, the return type, if there is a parameter, what are the parameters for these methods, and also we can know if it is a public or a private one, and all of them, they are public. So you can see, without writing any code, so now if I have this, just this class, I can go ahead and implement it. This is what you should do in your project and in any real-life case scenario later, that before you will go start implementation, make a draft, how we are going, or what we expect from different classes and variables and methods, and association. The word association mean here relationship. How these classes are related to each other.
I have a question.
What?
Is this like the UML? Is there a program or application for this, or is it just like something?
There are a huge amount of programs that you can use it.
Okay.
And I said program, it is a program to draw this diagram.
Yeah.
Yeah, there is a lot of diagrams. So I can give you a list of them. Some they are free, and some you have to pay for this. But there is a lot of programs that you can use it, and you can use your own way how to draw it. So it is a simple one. It's not a complicated one. But if you have a huge project, sometimes it's better to use a program, because there will be a predefined tool to just use them. So now let's go about what we name the class generalization, or which is similar to the concept of the inheritance. It's not similar, so it is the inheritance. So like here, for example, here we will have here a class account, and then we will have here 3 different classes as a child one. So if we are going to make or to present the inheritance here, we are going to use such kind of arrow. This is a must. This is the UML standard, that we are going to use this arrow one to tell. And if now I see this in a class diagram, for sure, here I have to add for each class the attributes, the methods. But if I can see this arrow, I can understand this is a parent or the superclass, and this is child 1, child 2, child 3. What about if I have an abstract class? So it is the same like here, but normally when we have an abstract class, we will do it as italic one. So if you are going to add this to your class diagram, it should be somehow italic one. So here we can see there we have a hierarchy here. So this child 1, child 2 for this parent and this is another class. Both of them, they are child for this class. We said that we can have in Java, can we have, is this a multiple inheritance, we said? Yes. However, so we can this hierarchical. If you remember, we said in Java, but the same class can be a child only for one class, but you will have a multi-level in Java. So what about this? This is an association. This class, it is not a child for this class, but it had a relationship. Normally, each customer in a bank will have different account. So we said the relationship, this is the multiplicity that I was talking about it. So one many, I didn't said 1 to 10 because he can open as much as an account he want to open at a bank based on the restriction of the bank. But normally there is no restriction how many number of accounts you are going to open in a bank. So in this case, I will also give sometimes name for the for this relationship. I can also, it is an optional one. So why is 1 to many? Why I have to add this in the class diagram? Because when I said each customer will have many accounts, later, after I will implement this class and this class, within this class, maybe I will create different objects. You have a checking account, you have a saving account. So here in this class, later I should create different objects from this class. This is why we said here, when you are designing the class diagram, you will add it as a 1 to many, which means you are going to expect here that different objects from this class will be created here and can be used here in this case. Here about inheritance. So as so far as we know about inheritance, that you will have the main class or the superclass, and you will have attribute, and we will see about the real case scenario later that you are going to see it. And you will have a method here and another method here. So, and I will have also the child class, but child class can have additional variable and additional method. But since it is a child class, it will inherit all this here. So I don't have to rewrite them again in the class diagram. Just since I put this sign, which means that this is a child for this. So no need to rewrite them here again. He's going to look at my class diagram. He can be well aware that, okay, here this class will have all this plus this. So if they are abstract and you are going to override them, in this case you can add them here also, because here we will have another implementation for them. So you can add it also to the class diagram in this case. Now we are done with the inheritance. So just we have to have this arrow, and if it is an abstract, we are going to make the superclass as an italic one. If not, we are going to do it non-italic one. And we should be aware if we are going to override this method, we have to add it again in the child if we want to do it. But also, some people will not do it, so it's up to us to do it like this. But normally, when it is an abstract one and you are going to re-implement it, you can add it in the child one. So now about aggregation association. So far there is two types of relationship. Either there is inheritance, we have a child and parent, or there is an association, which means that there is a relationship like the account and the customer. A customer have many accounts. But there is a special case from the relationship or the association, we name it aggregation. Some people will be confused between aggregation and inheritance. They are not the same. There is no relationship between them. Aggregation, it is a special kind of association. When I said association here, this is an association, which is a relationship, and this relationship has a name, and then it has a multiplicity. And a customer will have many accounts. However, aggregation, it is a special case of relationship where the relationship not only a customer will have, like the will have or belong to. No, here it is a part of. Again, it is not inheritance. Inheritance, it is an instance of, is a of, instance of. Human being is, and me, Ismail is, or Ismail can be an object in this case. Like say I want to talk about a human being, we will have another subclass based on different ethnicity group, like Asian one, European one, Indian one. So all they are subclasses from the human being, and then we can create different objects from each class, subclass. However, aggregation one is about when we will have a part that is when we have a class that will be part from this class, not an instance. Return back to the human being. If you are going to create a class for the leg one, leg arms. So the arm is apart from this. So sometimes I will create a class to go to make different variables for the arm. That are not global variables of the whole class. For example, we talk about the human being class. We will say, okay, human being will have height, weight. It will have skin color, whatever different variables. But sometimes, if I want to create a class for different part, so in this case, these classes are part of this class, but they are not a child for this class. So in the class diagram, we will use this diamond diagram, and still there is this multiplicity, like 1-to-1 or many-to-many. And so if it is 1-to-1, which means that in the it is not superclass. In this class, like here, mail messages, you will have only one body, but you can have many attachments. And the same attachment can be for different messages. For example, you have a file X. You can send it by this email, and you can send it by different email. So when you send it with this email, it is apart from this email. And when you send it with another email, it is apart from the second email. And when you are going to make implementation later, it will be a standing alone independent class. There is no inheritance, there is no extend. However, you should be aware that this will be later part from this other class. Okay, so Jason, is it clear about aggregation and the difference between aggregation and inheritance?
Kinda, but I don't know, like if we ever use the aggregation in actual Java.
Yeah, it will have. Wait, it is a design. So when we'll go to the Java, this will be an independent class, and this will be independent class. Totally independent.
Okay, I see.
So, but here when we are going, because according to the class diagram, as I said from the beginning, the class diagram will show you how many classes you will have, the name of the classes, the variables of the classes, the method of the classes, plus if there is a relationship, so you can understand more how these classes later, or how the object of these classes later is going to interact with each other. When I said a customer will have many accounts, so later you will expect that in the class of the customer, you will create different objects from this one. But it is not inherited from it is not inherited from this one, so you will not use an extend and the child one and superclass. There is nothing about inheritance. The same here, when you talk about aggregation, so this class will be part from this. However, it is a standing alone class, and this is an extending alone class. There is another type of association, which is a composition, very similar to this one, but composition, we can see it as a more strong, which means that you can find a message without a body, but you can find a message without attachment. So since it will be a strong one, we will add this a filled diamond in this case. Again, this is just the way you are going to describe your class in the diagram. Sometimes there is no aggregation in your project, like this example. So let's go to this example. Here we can see that this is a real case scenario for a booking system for a restaurant class diagram. So here we will have the booking system. We talk about different function we will have. Here we'll have the booking one, different variables, and then different methods we will have. And here we will have these two classes, two different kind of, you hear this word, two different kind, which means that talk different kind, talk about inheritance. So we will have the reservation, and then we will have the walk-in. So the reservation here, we will have the arrival time and set arrival. The walk-in, for example, here we don't have here specific variables so far, we have to add it here. But we can see using this sign, I can understand later when I will go to the coding that this class is a child, this is parent. Here, customer reservation. So this is a standing alone class, and this is a standing alone class. I make one to many, which means that each customer can have many reservations. So I expect later when I will create the object, for this object customer, I will associate different objects from reservation. So I can see this is a relationship to understand later more about the object interaction, how these objects is going to interact with each other. Later when I will create for example, especially in the main method where I will create different objects and I will call these objects to execute all functions that I will supposed to do it. And here as another class, and this is another class, and this is a third class. Sometimes I will add here a condition to consider it when I will go to implementation. So this is a real class diagram. So if I will look at this diagram, I can understand later how many files I should have, how many classes I'm going to have, and what are different methods in these classes, and later how the different objects from these classes is going to interact with each other. That we were talking about the interface. So sometimes we will have an interface. We know this. We will have abstract classes, we have classes, and we have interface when you talk about object-oriented. So the interface, we said when it is an abstract class, we will write it an italic one. And if it is not non-abstract, we don't use the italic font. However, if it is an interface, we will use the word this interface to tell that this is an interface, not a class. And later, when there is another class, because we will have a class that will implement this interface. So in inheritance, if we will have a class A, and then we will have a child 1, B, we will use this arrow sign. However, here we will use either we will have a dashed one because it is not extend, it implement, or we will use non-dashed one. However, we can use a circle to resemble the interface in this case. Both are used in the UML. So let's now talk about the payroll system that I want to share it with you today. Payroll system, suppose it is, I think so this example is most of us who give object-oriented, we will share this example. Let's talk about a case that you need to make a payroll system. So a company pays its employee a weekly, or suppose it's weekly one, or even though a base salary. The company has 4 types of the employee. Salaried employee who are paid a fixed salary regarding the number of the hour he worked. Hour employee who are paid by the hour, for example, wage and receive overtime pay, which is hourly employee. So if he will work more than the expected hour, he will be paid more. Most of the people who work with this. And we will have a commission employee who are paid a percentage of their sales. Based on the sales, will be paid. And the last one will be salaried commission one, who will receive a base salary plus a percentage. So for this current phase period, the company has decided to reward the salaried commission employee by adding 10% of their salary. The company wants to implement a Java application that performs its payroll calculation of their sales. So we are going to make a system that will calculate the earning for each one. And we have to consider that only this salaried commission one should be added 10% of their salary. Now tell me how many classes we will have here. Gerson, Jason, can you help me in this?
I'm trying to think, because there definitely wouldn't be just 4. There'd be more than 4, I think.
Okay, I think that they will be. Also based on this requirement, as I can see it, I can see that we will have 4 classes plus the main one.
Yeah.
Yeah, 5.
So forget about the main one, because the main one, it is a system one. So if I want to tell you to draw a UML diagram before you will start, how you will do it?
Well, I would start by just saying employee as a parent class, and all 4 of these employees would inherit.
So we'll have 5.
Yeah, that's what I was thinking, but I didn't know if there would be more than that. Like if there was going to be a function that would.
Wait. Okay, so far we said, you see, this is before you start coding, you have to do with your project. And this is the aim from sharing with you how to draw a UML diagram. So now let's start with this. So you said that there will be an employee which is the parent one.
Yeah.
I will give it M. So my question is for you, is it a normal class or an abstract one?
I would say no. I would say it's an abstract class.
What about you, Jason? What do you think?
Not sure this time. Sorry.
Why you said chaos notice should be abstract?
Because the amount that the method that goes to find the amount that the employees, the different 4 types of employees are being paid, like they have different, their employers have different methods of finding out how much they're going to be paid. So you can't just have one method.
And I liked your mind. You are an engineering one.
Thank you.
Yeah, 100% you are correct. So Jason, we had 4 different kind of employee. The salaried one, which will have a base fixed salary, the hourly one, which will pay based on hour, and then the commission one and the base plus commission. So the aim from this software is to calculate the earning of each one. So there is a method that will return the earning for each one. However, each one will have different way to calculate his own earning. So we agree that all employee is going to have an earning method. However, we can't have a one global implementation for this. So we will have different implementation for this method. And since there is no global general implementation for this method, then this method should be an abstract one. The method. And since the method is an abstract one, we need to have an abstract class. Because what is an abstract class? An abstract class is a class that can have an abstract method plus non-abstract one. So in this case, the employee should be an abstract one. We will define an earning method there, but without implementation. And in each class later, we are going to implement this method. Now the question is, okay, so we have the employee one and social security number, and we will have the earning and toString. And then we'll have the getSet method for this attribute. All of you should have a getSet methods. So if I go to the code part, I will have first name, last name, SSN, and then forget now about the construct. I will go later to this. Get first name, set first name. Get last name, set last name. Get SSN, set SSN. ToString, it will call the get one to print out all the values for this. And the earning, as we already agreed, this is the aim from doing this as an abstract, to have this method as an abstract. Since we have an abstract method, so this class is an abstract class now. We said we will not have an implementation for the earning in the employee level because we have 4 different categories, and each category in this case will have its own it will have its own implementation for the earning one. Any question, Kirsten, Jason, so far?
No, I'm good.
Perfect.
Same.
So let's go to the salaried employee. Salaried employee, we will have the base salary. Either it will be weekly one or monthly one. And then we are going to override. I think so, since it will extend the employee, so it will have the first name, last name, and the SSN coming from the employee. And it should have an additional, which one attribute talk about the base salary. After we will calculate the estimation, we will save it here. So, and we need to override the earning method and also override toString method. And for sure, we are going to implement the getSet method for all attributes that we will have it here. So here we will have a base salary, and then we will either we'll go to set weekly, or as I said, it's up to us weekly how we are going to do it, weekly or monthly, or I will do it. If I will go this, I will make it base salary maybe. It's up to you how you are going. If you consider it weekly, so keep it like this weekly one. So, and then, so the earning will get the weekly salary. If we will go, this weekly salary will retain the base salary in this case. And the base salary which will be calculated using set weekly salary. Is salary greater than 0, so the salary that we will have it later when we'll call this function or call the object or construct the object, we put it because we just have a salary in this case. And then we will enter the salary for this person, and then we will give it a 10%. No, this is not 10%. The 10% was for base salary plus commission one. So now what about the hourly pay employee? Hourly employee, we will have also extend one. And we will have additional attribute like the wage and the hours. Also, we will override the earning and toString and set the get and set method. So here, the hourly employee will extend the employee one. We will define the wage and hours. We will make a set wage, get wage, and then we will implement or override the abstract method since we are extending the employee one. And here we will say, okay, So in this one, the aim from the get and set, since they are private one, in order to access their value, we have to use the get method. So we will get wage, get hours. We will either, if it is less than 40, we'll do it like this. If it will be more, we will calculate it more in this case, since we have an overtime, according to the requirement that we get it here. This is a requirement that we receive it from our client, that he's going to use our software. So what about hourly employee? Oh, sorry, we will here. And then you see here, and then we said, okay, toString, nothing more to do it, since just we will call the superclass, nothing to be added. We need all the first name, last name, and the SSN. So, and we have the earning that we return the earning based on this calculation. Commission one, commission plus the first name SSN that will inherit it from the employee. We need to have the gross sales and the commission rate in order to calculate the earning. So get set, and then we will go to the earning here. It will be get commission rate multiplied by get gross sales. How much he has already paid, how much he has already sold, multiplied by the commission rate. The commission rate, as I said, when we will going to define variables, here's this. Either these variables, we will use it to get an input from the user later, and then we need to save this input in a variable, or there is an output, we want to save it in a variable. So here we will have the input, we need to know the gross sales and the commission in order to calculate the earning, because we have to multiply it. And so this is why I will make this two variable that I should use it here. The last one is about base salary plus commission. So we will have the base salary, similar to the salary one, but however, the base salary we have to consider, we will talk about it, so we'll have only the salary one. And when we are going to calculate the earning, see this. By the way, it should going to extend the employee, not as we did it, we didn't consider it like this. Because the commission, it's based on the commission plus additional. So in this case, if we return back to the ER diagram that we have considered, it should be an employee, and then we will have like this here. We will have the hourly, commission, salary, and under commission, we will have the salary plus commission. So it's extend commission that extend its employee. So when we talk about earning, you use this word, super earning. When we talk about super, which is a commission, it's better to do it like this. Do you know why? Because since here we calculate the commission, and when you talk about commission salary, which means that he was going to have a commission plus the salary. So I will use super earning, which is will return here, plus the salary that we are going to get it as an input in this way. Guys, is it okay base commission salary extend commission, or you should extend employee? Which one you prefer? And if you do it like this, what will be the advantage? How we can do it? If we will do it like this, what is the advantage and which one we have to go with it? So do we have to do it extend employee or commission employee?
Commission employee.
Why? Why not employee?
Because if we extend employee, we need to rewrite the part of method that we calculate the the percentage of and the gross earning, those things. So it's like a duplicate of the code. We don't have to do that.
Yeah.
Right.
So since there is a method that we are going to use it in the commission one, So we are going to extend it in order that we can use it, and based on this method, we can add other resources to it, which is the base salary, to do it. So if we will go to the employee, we are going to re-implement the same what we have already done it in the commission one, and adding the salary. So in this case, it's better to use a commission employee. Before I will go, let me change what I'm sharing. I will share another screen here, the code one, because I will show you here the main method. Here, this is what we have already discussed, employee, commission one. Can you see my screen, guys?
Yes.
Yeah, I can see
employee, let's now hourly employee, salaried employee, base plus commission one. So this is all what we have already discussed. Let's go now to the main one. Always in the main, we'll create different objects for different classes. And then if this object will interact with each other, they will interact here. But here now, we're not talking about objects that will interact with each other. We talk about only inheritance. There is no other association in our class diagram. So I use here an array, since I just want to create a for, but like the assignment that I give it to you, you will use an array list, because we will ask the user about the number of objects or that you're going to do it. I use this name like George Bush, but I keep it based on the resources. I use it. John McCain, Barack Obama, and each one. So according to, I will construct all these objects as we defined here. Commission employee will take the first name, the last name, the SSN, the weekly sales, the percent, as we have already mentioned here. So, and then I will construct and give the, like here, the commission, we will give the wage and the commission rate and the sales in order that you can calculate them based on the constructor. And then I will make a loop to print out each of one of them. And here, if, because according to the requirement, we have to multiply it or give 10% only to the base commission. I said here, if it is a base commission one, so I said, if it is a base commission, it is an instance of this. By the way, you can use this word, maybe the first time we will use it here is instance of. And you will use it in order to double check if this object comes from this class, yes, no. So here I will multiply it by 1.10. And then I will, the output, I will consider as the earning for this one. And finally, I will make get class and get name to print them all out. If I run it now, so here I can see here the salary of the employee for George Bush, what was, and the SSN, the weekly salary, the earned one, the hourly employee Bill Clinton about the SSN earned, the commission. It calculates everything for me here. And later it will give me again about each one, the different details about what type of class I use for this. This is a real project. Yeah, if to go to more real, we should have a graphical user interface. But now, as I said, in this course, we will not learn graphical user interface. We will focus more about the core of the object-oriented. This is what I want to share with you today about how you design your class diagram before you start your implementation, and to give you a real case scenario about object-oriented case when we talk about here payroll earning. I expect to have similar projects from your side, maybe with a more bigger scope. I said it is a group-based one. I hope that you have already talked with each other, each one of you who is in a group. When I will publish the group list, so project list, I will give you sample project, but also you can propose your own. And when I will propose a sample project, like always I will do in all my courses, I will not be very restricted in the description of the project. So I will keep for each one of you to define the detailed requirement of his or her project. Gerson, Jason, do you have a question for today?
No, I'm good.
So when you say we have to make our own details, does that mean like when we choose the project, we have to like build more like restrictions on what we're gonna do?
Yeah, you will make more detailed requirement, because I will give you just on the idea of the project, but you have to go more detailed. Because if I will go more detailed, I will make more restriction. I will be interested, since we will have different groups. There's the same project title. I can see different implementation for this based on the requirement definition. This is the aim.
Okay.
So in this case, you don't have to ask me for the approval of the detailed project, the detailed description. Each group can make its own description, detailed description, without any approval from my side. But if you will choose a project out of the list, I will ask you to send me an email to give the approval for the idea.
Okay, that sounds good.
Yeah, but I also don't forget that either you are going to make a presentation in the last lecture. I will put this all in the guidelines. And since it is asynchronous course, in this case, I will ask you in this case to make an offline recorded presentation and share it with me.
Oh, it's going to be offline instead of a presentation?
I will give the two options. So either you will make it offline internally in the group, and then you record it and you share the video with me, or you will be here at the end of at the last lecture and you present it live. I prefer that you present it live, since if I have any question, I can ask you, and maybe it will be better for you. But if some groups, they will not able to do it here because of their time restriction, so they can record the presentation and share it with me. But it is a must to have a presentation.
Okay, and then so it's going to be like last semester where we had the presentation and the final exam?
Yes.
Okay.
It will be at the end of the semester. The deadline with the project will be the end of the semester.
That's like April 14th, right?
Yeah.
Okay.
So it will be, I think April 14th will be also Thursday. So it will be the April 14th, the deadline for the project.
Sounds good.
I think that after this case that we discussed it will be more easier to think about your project. It will be easier to you in this case.
Oh, okay.
Okay.
Jason, what about you? Do you want to ask me something or discuss anything with me?
No, I'm good.
Guys, have a nice evening. Thank you for being here. By the way, that you are being here, I consider, even though today we don't have a question, but I highly appreciate this, because this interaction really it is all who is going to watch this video also will benefit from this.
Yeah.
We're happy to help, me and Jason.
Okay. Have a nice evening. Take care.
Yeah, you too. Thanks. Bye.
Bye-bye.